Hi, this is Laura Jasmine, and I want to talk to you about the spatial, temporal, and conceptual systematization of paleoclimate information and the preliminary analysis conducted in quaternary records in Mexico. For starters, I would like to put you all in context regarding the paleoenvironmental and paleoclimatic studies that have been conducted in Mexico. Since its origin around the mid to late 70s, they have been primarily focused on isolated analysis in several paleoclimatic archives. But in the 2000, Metcalf and her team presented a countrywide analysis where they divided Mexico in three regions that we can see here in the map in the red dotted polygons, according mainly to the information availability back then. Ever since 1989, we have had many regional studies that encompass smaller areas and focus mainly in central Mexico or the Yucatan Peninsula. And while most of these studies acknowledge to some extent the influence of the specific characteristics inherent to the geographic location, the basis for the selection of these regions tends to obey other factors. But that's not all, because since these studies are conducted by researchers that study paleoclimate from different perspectives, they tend to have different nomenclatures. And a clear example of this is the Lake Archive nomenclatures, where the same exact site can be referred to as a lago, laguna, olla, estanque, humedal, cenote, and a very colorful, etc. And even though multiple authors have taken steps towards some sort of systematization, these steps are still heavily dependent on the discipline, and thus they lack comparability, bringing up again the need of a standardization from a pure paleoclimatic point of view. And finally, to achieve comparability among paleoclimatic studies, we have to also take into account some deficiencies in the age models attached, derived from mistakes applying correct methodology, some from analysis and interpretation, and some from the reporting and representation of information. And there's the consideration about the trends in age modeling. While the first studies all use linear interpolation methods, currently most of them tend to use Bayesian methods. So with all of this in mind, we took the paleoclimatic and environmental information available for Mexico, and this comprises 355 studies, including lake sediments, speleothems, glaciers, sedimentary formations that were published in research papers, both peer-reviewed and non-peer-reviewed. This is book chapters, Congress memoirs, and we selected those that included both a paleoclimatic interpretation and a time component. All this data, as we can see, is very diverse in their dating methods, in the age depth models, and the proxies they use to interpret the paleoclimate. And with this information, we propose to characterize all possible paleoclimate basins, clustering and hierarchizing according to three criteria. The tectonic context from Vera Torres in 1994 that considers 5 classes, the basin genesis and sedimentary environment by Hutchinson in 1957, composed by 11 classes, and the sedimentary input classifications by Bohax in the 2000s, which considers 3 types of basins. This process gives us 165 possible classes. On the other hand, we postulated a conceptual and a logic geographic information system model, which considers 4 data sources for a paleoclimate regionalization, the 355 isolated paleoenvironmental studies from our dataset, the geohydrologic basins from Velázquez Aguirre and Ordaz Ayala in 1992, the climatic regions by Copen Garcia in 2004, and the physiographic provinces by INEGI in 2001. Then we applied a weighted ledger superposition and a correlation analysis among all these data sources, which brought us from here to here. Finally, for the age standardization, we acknowledge that the ideal step would be to take the original chronology information from all of these studies and recompute the age model. But since some of these studies were conducted so long ago and a lot of the authors have become unreachable, the middle ground for now is to parameterize and apply a weighting system in order to recompute the uncertainties of these records under the same framework. Considering for this, according to the literature, the date density, the date extrapolation at these dates, and the justification of the age model parameters. So after working with 165 possible classes, we applied this hierarchy, first tectonics, then genesis and input, and then discarded all the non-applicable classes. And then we got 126 paleoclimate basin classes, considering the 3 parameters, in which tectonics will give us an idea of the types of proxies that can be encountered, the geographic barriers between basins, and the specific climatic events within these barriers. The genesis and environment will control the depth, area, and time resolution of the basin, as well as its recording capability. And its sedimentary input parameter will tell us about the time resolution as well, but also climatic events and types of sediments, and that is the information that we can get from the basin. Now, regionalization yielded 3 regions and 37 subregions. Mainly, we divided the country in the northern, the central southern, and the southeastern regions. They share the same geographic paleoclimate characteristics in general, but in a larger scale, we have a 17, 15, and 5 subregions. And from the northern region, we identify the Cuencas Cerradas del Norte subregion for having the most amount of studies, 3 studies, while in the central southern region, these 3 subregions, Lerma Santiago, Pánuco, and Balsas, have 8 studies each for a total of 24. And in the southeastern region, the region with the most studies, Yucatán Norte, features 12 studies. Lastly, the recomputed uncertainty, while it is a provisional solution, gave us some immediate insights as to what the real time span of the available studies probably is. We can see here in the left side, we have for the central southern region, these are only the average ages. And on the right, we can see the ages, including the recomputed uncertainty. And that allows us to, for instance, compare records from Aljojuca Lake to those with Xochimilco. And this is a very necessary analysis that was previously impossible. So all in all, we can state that this work is the first strictly environmental basin characterization that we have for Mexico, and we can infer that this will help us have a better comparability and even correlate this characteristic with the paleoclimatic signals. This could also help us optimize the identification and the restriction of regional paleoclimatic patterns, and could have several applications in geostatistics and data science. Finally, this could be the way to reinterpreting the chronostratigraphic time divisions currently used in most of these studies according to the real climate context for the Quaternary in Mexico. And well, all of this looks very beautiful, but let's not forget that it's just one more step towards the systematization of the paleoclimatic information and a centralized data integration. This could one day lead to interdisciplinarity and a unified language for later studies, but currently we need to keep assessing the performance of the system in more regional studies and tune in some details, but for now we can consider it as a standardized framework for reporting environmental information in future research. And well, that's all. I invite you to check out my references, and I would like to thank CEST, the PAPIME 10 2024 project, and the Seminar of Paleoenvironments and Paleoclimates of NS Morelia. And of course, thank you all. And if you have any questions or feedback, I would greatly appreciate it. Thank you.